Hi everybody, my name is Andy Matuschak. The last name is hard to pronounce and I apologize for that. I'm probably actually mispronouncing it relative to my Slavic ancestors. And for the past many years, I worked at Apple on the UITouch team. I left in June and I now lead mobile engineering at Khan Academy. And I'm going to be talking today about a squishier subject. And there will still be technical content. Don't worry, I'm actually going to expand on some of the concepts that Justin introduced. But really, it gets to how we can function as a community while collectively we share and exploit our excitement with Swift. Now, I will ask you to bear with me a little bit. I've contracted a cold, and the structure of this talk requires me to speak at my normal pace. However, this is cotton right now, so we'll see if we can make that happen, and I hope I won't get you all too over time. Swift is a brave new world for functional programming. It appears to suggest in a number of ways that functional programming may be the way forward, or certainly it enables a whole lot of it. So there's a huge opportunity for all of us to bring some of these more academic, more rigorous, more expressive concepts to traditional industry engineers who are used to working in a procedural, imperative, stateful, object-oriented environment. That is really exciting. It's a great opportunity, but it's also a huge opportunity for culture clash. So I've been seeing around the internet and around discussions at coffee and even an internal Apple mailing list before I left, camps starting to form. And I'm a little worried about these camps. The camps look a little bit like this. All the way on the one side are example projects coming from Swift that look basically like machine translation of Objective-C. It's a little bit like if you were to feed some Italian into a computer and it kind of went word by word and translated that Italian word into English. Like that's what one of these camps produce. All the way on the other side is SwiftML, basically, people pretending that this language kind of is a thing that it isn't, and trying to use it to go all the way over to these things that they're used to from pure functional languages. And another way that I saw this on mailing lists was one camp of people asking, where's my perform selector? And the other camp of people asking, why can't I write functor? So this is something that we're going to have to work out a little bit together if we want to avoid an us versus them mentality. Those of us who are familiar with functional paradigms and the power that they can bring have an opportunity here to educate others and to share that. But we also have a responsibility not to alienate our peers and create turf wars. I dealt with this recently myself because I'm now leading a team, and I have some engineers on that team who are not at all familiar with functional practices. But we're using Swift in production, which is fun. And my natural tendency is to move in the functional way. So we had to think carefully about how to do that responsibly, and in a way which would not alienate not only current team members, but potential existing team members, because I'm hiring. And we have to have new people be able to read the code base. So it's not good enough for me to just teach them all this functional stuff. I can't just give some classes and be done. No, in order for us to use functional paradigms within our code, we really need a significant fraction of the community to understand those paradigms, or else it's going to be hard for us to bring new people on board. Fundamentally, I think it gets back to an issue that Justin brought up, introduced again by Mr. Hickey, the difference between easy and simple. And for the sake of the video, I will rapidly review. Easy things are familiar. They're close to hand. And an example that I like to use of this is if any of you play an instrument, you go through a whole bunch of stages where initially you're really focused on like muscles and moving your fingers to the right place on the instrument. And maybe then once you've got that, you're spending all of your brain power on translating the dots on the page into musical notes. And eventually those things become close to hand. Those things become automatic, and they're easy. You focus on progressively harder and harder things. But that concept is different from what is simple, involving few concerns here in engineering. So S expressions are simple. They're great. Objects are not simple. Objects do not have few concerns. Objects collect state, functionality, inheritance, and reference. It's a whole lot of things and yet we think of them as this fundamental concept, which means that we have a lot of work to do if we are to integrate into the object-oriented community. Returning to the musical metaphor for a moment, the clarity of a musical idea is orthogonal to the challenge of performing that musical idea. So if we take a look at this, this is an example, really, I mean, to me, a lovely example of solving the horrible JSON decoding problem in Swift. This is Argo. This is far away from most people. There are 1, 2, 3, 4 novel operators here that most people will not have seen. So that's not close to hand. It's not subconsciously automated. And worst of all, and this is the part that I want to impress upon you, this is so far away that a naive reader can't even appreciate the benefits being conferred. And when they can't appreciate the benefits, they certainly can't see why it's worth understanding all of these things that will be necessary to bring these concepts close to hand. So why would they bother to do so? You have to read a whole book to understand what's going on there. There's no lightweight introduction. There's a functional programming in Swift book, but you have to be the kind of person who says, oh, I want to read a functional programming in Swift book in order to benefit from that. And that actually is inherently a bit limiting. There's no smooth curve. Concepts have a cost. Every new concept has a cost. And a great way that we can see that is the delegate pattern. It's just this age-old Cocoa pattern, and it's like it's overused in a lot of ways, but you know, the huge advantage of it is that for your typical iOS developer, when they think about, I've got this object that needs to pass an event back up to an unknown owner, they just think, oh, cool, delegate, I got that. And they're done thinking. And maybe it's not great that they're done thinking, but actually I would argue that most of the time, you know, that's fine. It's fine. And so if we add on extra concepts here, you know, oh, there's an event propagator that this object can now emit on and the parent can subscribe to, you know, in some cases that provides benefit that's worthy of the cost, but in many cases it's just adding cost. So here's where I relate this to my new gig. I'm at Khan Academy, and our goal is a free world-class education for everybody, which means I now spend a lot of time reading papers about education. This is a thing that comes up a lot. You can't answer a question that hasn't been asked. If somebody hasn't decided that it's within their interest to read a functional programming in Swift book, you showing them that page of Argo code is unlikely to persuade them to do so. We have to get people to ask the questions related to these things if we want them to use them. So my proposal is that we exploit pain. JSON is really painful in Swift, I gotta say. There's all these optionals everywhere, and there's casting implicit in everything, and so it's great for conversations about how we might approach things more principally. Also for conversations about how people miss Objective-C. And that's something that I think we have to be honest about as functionalists as we look through this stuff, because there's a constant cost-benefit analysis. At any given time, when you're proposing an approach, it may be simpler, but the ease of that idea will differ depending on the person that you're communicating with, and therefore the cost will differ. So you have to be thinking about the benefit that you're providing to that person, not just now, but in the future, versus the benefit that they will receive from that knowledge now and in the future. Sometimes what you're suggesting will cost a great deal now, but it'll give them a great deal of benefit now, and so it sounds good. Unfortunately, a lot of the time what we're dealing with is something that will cost a fair amount now and will not yield any benefit until long into the future. And that is much more difficult. The explanation of the benefit you provide can't just be, it's more functional. We got to do better than that. So I'm hoping for a more incremental path to integrating these worlds together. And one of the examples that I like is optional's map function. So the optional type has a map function, and the behavior is something that Swift developers encounter almost immediately coming from the Objective-C world to Swift, and that's that I have this chain of functions. Each one is emitting an optional, and I want to only do the next one if the previous one emitted some value. Optional.map does that. So great, that's something that you can communicate really quickly. It comes up in code review. Somebody's like, this is kind of gross, but I don't know a better way to do it. You say, check out optional map. And they're like, oh, cool, okay. And they can get that really quick, and then they can use it. And now they've learned about map. And that's great, because then you can have a conversation about how optional.map is like array.map. Although, cautionary tale here. I had a team member try to implement dictionary.map. And dictionary.map is interesting because for every key value pair, you need to ensure that the mapped output produces a unique key in order for it to truly be a legal implementation of map. So for instance, if you have a dictionary with 2 keys and values, and you map each of those key value pairs to having the same key, then now you have a dictionary with 1 key and value on the other side, and that's not legal. So when we introduce these things incrementally, we have to be sure to do so responsibly and not just say, okay, optional.map, it's magic. But hopefully we can keep people in the zone of proximal development. And this is, again, an educational pedagogical concept. And the strategy here is that we're trying to keep people right at the edge of their interest and their ability and their knowledge. So I'm trying to find ways to have developers frequently have lightweight encounters with opportunities to explore these novel paradigms. And one of the ways that's been most successful for me so far is what I call the value layer game. And this is an expansion of the concept that Justin introduced. So I'm going to try to go through how I introduced this to my team. I introduced it somewhat more broadly to the community on OBC.io and at CocoaConf a couple months ago. So this will be an introduction of the concept aimed more at people who already understand the concept. But I've tried to carefully construct the way I introduce it to be easy, to be familiar to people who are used to programming in imperative object-oriented environments. We have to phrase the benefits in ways that they can understand. This is a conversation that very quickly happens as soon as an OBC developer moves to Swift. Because NS arrays are reference types in Objective-C, and very rapidly they run into the fact that they are not reference types in Swift and create bugs as a result. So great, that's a great learning moment. We can talk about that. They run into this problem. We talk about the fact that arrays are value types in Swift. And we say, hey, but that's pretty familiar, right? Because, you're used to CG size being a value type in Objective-C. So that's all okay. Value types are just things that are copied on assignment. They have a single owner. And there are just more of them in Swift. They're more powerful. Structs, enums, those things you're used to, we just use them more in Swift. And arrays are structs now instead of classes. So that's a pretty easy introduction, and we say that, okay, this thing that you're mostly used to dealing with, these reference types, they're just shared on assignment. They're multiple owners. That's objects, closures. It's just like in Objective-C, so again, I think that's a pretty friendly way to start. And it helps to be able to point out the fact that there is one class in the Swift standard library and a whole lot of value types. So as soon as this is realized, as soon as we start having this conversation about the arrays, and the question becomes, okay, so why did Swift's language designers do this thing? Often it's kind of phrased with some animosity, like, why have they done this to us? But I have a way that I've been using to explain it that I think is effective for people from the object-oriented world. And I talk about the 3 I's of value types. They are inert, they are isolated, and they are interchangeable. You can make objects that have these properties, and I'm going to define them in detail in a moment and talk about how I introduce them to object-oriented developers. You can define objects that have these behaviors, but value types pretty much always have these behaviors, and so you have a better guarantee. And that's the argument I've been making. So what do I mean by inertness? Value types don't behave. Objects behave. Often you send them a method, and they do some stuff. So here, we've got a view, and we change the number of bloops, and it begins an animation, and it's got a completion handler, so now we got time involved here. And boy, it's really not clear what happens if I change the center x value before the completion handler calls back. There's potential race conditions here. But really, this style of code is only possible because the timer also has a reference to this view. If you have a value type, you can't write this kind of code. Stuff that is code that exists within a struct method is not going to execute outside of the context of being called by the owner. So I think that's a benefit that is non-academic and is fairly easy to introduce to Objective-C developers. Value types are also isolated. There were some pretty sweet diagrams for this in the WWDC talk that I gave with Colin, number 229. But hey, I think they're owned by Apple, so I can't show them to you. But the concept goes that reference types create implicit dependencies. Whenever you pass an object around the system, every component which receives that object has an implicit dependency on every other owner of that object. It's not visible in the code, not clear what the side effects of that will be, but here's a ridiculous example. So you have a user, and the user needs some donuts, and there's a donut controller that can get some donuts. Maybe it's an intern. And so you give the user to the donut controller, and here the user is a reference. It's an object. And if something else, some other controller, also owns that same user, that other controller could change the number of donuts that are needed before that request comes back. And it's not clear what the intended semantic is. Maybe it's OK. If the user ends up needing more donuts later, then we'll just get them later. And maybe the intended semantic is that if the user ends up needing more donuts, when this request comes back, then we should send the intern out again. It's not clear. This code is not isolated. So again, every time you pass a reference around, you create an implicit dependency. That, again, I believe is not a very academic concept. It's not functional, but it relates in important ways to a lot of the functional concepts that we're trying to promote. Finally, value types are interchangeable. You can't tell the difference between two instances of the same value type which have the same data. And this one is very familiar, I've found, to Cocoa developers, because have you ever tried to make a UITouch? They have hidden handshakes to the rest of the system. It's impossible. You can't just make one. If you do make one, it's not interchangeable, which means you can't write unit tests. You can't make stuff that consumes and produces UITouches. You can't write them down. You can't move your boundaries. This, again, gets back to that Gary Bernhardt talk, which is wonderful, and you should watch it. So the code you're writing, which use these APIs, is less general as a result, because you can't rearrange the components in your graph. Here's an example I'm going to come back to a few times. This is for finger drawing. You have an iOS app. You can draw on the screen with your finger. This exists in the forthcoming Khan Academy app, and we basically did it this way. It's all modeled with value types. So there's a drawing. A drawing is a series of actions. An action is a series of touch samples using a particular tool, where the tool might be a pencil or an eraser. And a touch sample is just a location and a timestamp. So all of these things are value types. All of them are inert. All of them are interchangeable. And all of them are isolated. This means that we can do something like render drawing that produces an image from a drawing. And this function does not care where that drawing comes from. You could have loaded it from a file. You could have just made it in your unit test. Your view controller could be storing it. Doesn't matter. And the value in that is that, iOS touch devices have a lot of latency in the touch handling, so often you want to project where the user's touch is going to be. So say that you wanted to add that in. It's very simple if you're in value land, because you can make a value-oriented function that takes a sequence of touch samples and projects where the next one's going to be based on the motion. And because everything is just dealing with these interchangeable value types now, we can go ahead and construct a projected drawing using that project function and render an image out of that. And our render drawing code has no idea. We never could have done that with UITouch, because UITouch has hidden handshakes and it's entangled with everything. This also means that we don't need mocking. Justin touched on this, but it's really wonderful. This projected touch code that we've written we can just create a sequence of touch samples in a unit test, project the touch forward, and look at the result. Data in, data out. We're not setting up the world, telling the world to change, and then looking around at how the world has changed. No mocking needed. So those are the 3 I's, and this is the way that I've been explaining this concept of the value of values to object-oriented engineers. And then the question becomes, what about objects? What are they good for? Brett Victor has a talk about digital art that I like a lot. I'm going to steal for a minute here. He says the essence of the interactive medium is that the objects we create within it behave and respond, which incidentally is why I'm excited about the untapped potential of educational content in this medium. But anyway, values are dead. They can't behave and respond. That's why we like them. The inertness gives them all those nice properties that we've been talking about, so we need to find a way to talk about stable entities within the system. And we also need a good answer for all of these object-oriented developers who are saying, we like objects. When do we keep using them? And we're working with these frameworks that are also all object-oriented, so how do we do that? What stuff lives in the object land of the framework? So, the metaphor I've been using is a zoetrope. If you remember this thing, this is a primitive animation device. You have a carousel with fixed static images around the outside, and as you spin it and you look in the mirror in the center, you see an animation over time. The idea here is that the images around the outside are like values. The static, they don't change. And this thing in the middle is this appearingly stable entity that evolves and responds to the motion of the device. Many dead values can together make one living identity. The values are inert, they don't change, they're snapshots, but a sequence of them causally related can create a persistent identity. And that's what objects are for. This is very similar to the view model concept that Justin introduced. In fact, you could call this canvas controller a canvas view model, and you'd pretty much be there. And the idea is that maybe you got a drawing just like the one that we talked about earlier, where a drawing is a sequence of actions and so on and so forth, and it exists within a canvas controller. The canvas is the stable identity that the user interacts with. It evolves over time. And a drawing is just an instantaneous snapshot. And so here the canvas captures the current drawing. And current is particularly meaningful in this context. It's a sign, it's a fence pole when you see current or previous or something like that, that it's a label for one of those snapshots within a stream of immutable values continuing over time. And here I get to a possibly elaborated definition of what state is, also stolen from Rich Hickey. Clearly has had a lot of influence on these past 2 speakers. But the idea is that state is an identity's value at some time. So the identity is the canvas, it's evolving over time. The value is a single drawing. And the state is an identity's value at a single time. These are the definitions we're going to roll with for now. So the role of objects then, well, they have identity by default in Swift. If you pass a bunch of them around, they all refer to the same thing, so all the clients can see the same state, and this allows us to make a stable picture of any definition of state that we want within our application. So here's what I think objects are for. And I actually think this is like a pretty familiar way to think about objects for an object-oriented engineer. Objects represent identity. I think that's reasonably familiar. It's the classic example of object-oriented programming is, Fido the dog. Fido is an identity. Objects represent that identity. Objects manage state transitions, so they have variable properties, and they change those variable properties over time. And they perform side effects, so they might hit the network or draw to the screen or something like this. But the values can have much of the logic. So here, back to this canvas controller a minute. The canvas controller owns the current drawing, which is in a variable, so it can change, even though the drawings themselves are immutable values. And the canvas might receive events, like touches from the system, but it's not really going to do anything. It's just going to delegate down to the value layer for all of the interesting behavior. It's going to update its current drawing to something computed using the value layer. And that's really what I'm getting at here. So I've been proposing that we think of our program in terms of two layers, the object layer and the value layer. The object layer is made of objects, which represent those identities that coordinate state transitions, just as we talked about. That's the layer that interacts with UIKit, which is a critical thing to talk about in any proposal for how we should use Swift. You know, you have to use these frameworks if we're actually going to build a thing. And the value layer, in turn, can have all those nice properties of being inert and being isolated and being interchangeable. And therefore, hopefully, all the interesting stuff can live in the value layer. And this is really the game that I've been trying to push on my team and on others, is, okay, so you've added some code. We're looking at the code review together. And you've added a bunch of code to a view controller. And we can point to part of it. And we can say, hey, it looks like that's pretty isolated. Or that's just like a computation of values. Like, why don't we push that down to the value layer? And say, okay, yeah, that's good. And this creates a continuous opportunity for conversations about transformations of immutable values, which is pretty much what functional programming is. I mean, the funny thing is that it's also a little bit what object-oriented programming is. You know, this is a classic adage in object-oriented programming: separate logic from action. I mean, we're doing it a little more principally. No one should ever watch this video. We're doing it a little differently. But this is a pretty familiar concept to object-oriented engineers. We're treating it a little differently. We're going to try to maximize the value layer. So here's an example of the way we actually did this for this drawing behavior in the app. Say that you want to update the drawing when a user's touch arrives. So you get a touch, and you're going to incorporate it into the drawing. You're going to estimate the velocity of that touch using previous touches, because we're going to make the ink look different when you're moving at different speeds. We're going to smooth the touch samples, because iOS only gives us touch samples at 60 hertz, and if we don't smooth them, they'll look blocky. And then we'll compute the stroke geometry based on the velocities and the smooth samples. And finally, we'll render that stroke. So we'll just put all that in UI view. We can do a little better. So if we walk through these things, we can find ways to make elements of this process testable, expandable, have the boundaries be movable, and we'll get isolated, inert, interchangeable behavior. And also, probably, some good practicums, that's probably not a word, about functional programming. So, estimating touch velocity. That seems like values. Take a bunch of touch samples, return some velocities, here described as CG points. And you know, here it's a static extension on touch sample. You can make it a free function. I find that freaks out object-oriented engineers a little more. So that's fine. This is fine. Just roll with this. Think of touch sample as like a module. That's fine. And this is an opportunity to talk about map. So that's nice. And when we need to smooth the touch sample curves, that also sounds like value in, value out. We're going to take a bunch of touch samples. We're going to make more touch samples for each pair of touch samples. We're going to produce an interpolated set of samples in between. And that sounds like an opportunity to talk about concat. And here, when we're computing stroke geometry, we're going to take a drawing action, which I'll remind you is a series of touch samples and a tool, and we're going to produce a Bezier path, say, or maybe some value-oriented geometry. And this sounds like maybe a fold. I don't know. It's another opportunity to talk about transformations of values into other values. And you know, incorporating the touch into the drawing in the first place, that can also be value-oriented. That can be, say, a mutating function on the drawing, or it could be a drawing function that returns another drawing. But really, like, we're left with just these two things that exist at the object layer. Updating the state, which is just an assignment to a variable, and rendering the stroke, which is probably setting the path on a CA shape layer or something. So we've succeeded, in this example, in creating a thick value layer and a thin object layer. But more importantly, hopefully, we've succeeded in creating opportunities for talking about some of these functional paradigms. We're talking about transformations from data into new data that's isolated from the rest of the system. And that's inert, that's interchangeable. And we have a lot of flexibility here as we do this to stay within that zone of proximal development. Because if it seems like fold is not going to be a welcome introduction at a particular time, that's fine. Like, let's not use fold. We can use it for the next thing. Let's just use a for loop. It's okay. It's okay. So we'll do this together. We can grow a community of people who actually understand these concepts and who aren't just like angry at all of the arrogant functional developers together. And that way, hopefully, we can actually work on teams that are willing to use these concepts without having to make mandates and use fiat and dogma. One of my teammates asked, I think very justifiably, are we only going to be able to hire super geniuses if we keep doing this stuff? I'm not sure that's quite the way I would phrase it, but I think it's a legitimate concern. And so we have to move together as a community. Thanks. Please.
So, like, on your team, you're the leader, so you can kind of push the team forward. But what do you recommend kind of the other way around, where there's someone on the team who's not the senior engineer?
Yeah. So the question was, if you don't have, if you aren't able to strong arm your team into this paradigm, what should you do? Right. I think that's a great question. I'm trying real hard not to strong arm my team. So my hope is that it's not the case that the only reason we're doing this is because I'm making everybody do this. That might actually be the case. But I would propose that this object layer, value layer dichotomy, as I've outlined it, is easy enough, is near to hand enough, that number one, you can get away with making these kinds of changes within your own code reviews or within your own patches. So you set an example, and hopefully you can set an example showing that, for instance, your unit tests are much more succinct and readable, or that you have fewer defects. And secondly, code review is a great opportunity to have these discussions constantly, as it is a great opportunity to have discussions about engineering practice in general.
You started your talk with the thing that when you design a system, just free your mind from all this object-oriented stuff and kind of things like that, and try to propose it to whoever kind of put a stamp on it, like, okay, we go this way. But what about the cases when you got into the team with a bunch of legacy code, and somehow you have to deal with that?
Yeah.
Obviously, everybody wants, maybe.
Yeah.
But what's your
Sure.
kind of advice to this? Just keep it done and wait until somebody says, okay, we will write everything from scratch.
Yeah.
Or do it somehow incrementally, but the trick is how.
Yeah, okay. How do you deal with legacy code? Good question. Yeah, you do it incrementally. I think a straightforward way to do it incrementally is if you have a big fat object, you can take incrementally the interesting parts of that object and move them into the value layer. And external clients of that object don't have to know that that's happening. And it's true that external clients of that object are still going to treat it as a reference, but you are moving more of the logic down to a inert, isolated, interchangeable place. And then ultimately, you'll have to bite the bullet and change the client call sites as well. Ken Kashenda gave a really good talk about this 2 years ago at WWDC. I don't remember what it was called. Search for Ken Kashenda at WWDC and you'll see it. He talked about how the WebKit team has managed to maintain really high code quality over time. And their philosophy is that you're never going to get a chance for that big rewrite. And the only way to have a happy code base is to just be continuously refactoring in an incremental way.
You talked about introducing these ideas as being easy, familiar to object-oriented programmers. Have you had any problems with the idea of transforming values to values and performance concerns that could come up with that?
Yeah. I mean, okay, so the question is, what about performance concerns of value-oriented programming? That's a great question. Those concerns are real, and they've actually had impact. And when I did this drawing thing, actually, I initially did it in Objective-C. And in Objective-C, it's difficult to write good value-oriented code. I actually ended up having to use objects because values are bad in Objective-C. And it had huge negative impact on performance that actually my teammates correctly called out in the code review. And I was like, well, let's just see. And like, no, it was bad. So then I had to rewrite it all with structs, which means I couldn't use arrays, and it was terrible. And this continues to be a problem even with Swift. Swift is reasonably smart about value types in a number of ways, but some of its value types have special behaviors. So for instance, array has value semantics, but it uses reference types in its implementation. Excuse me, arrays are copy on write. So if you assign an array to a number of slots and then you don't change anything, then they all share the same backing buffer. And if you change just one of them, then only the affected slots will change, and a copy will only happen then for, I don't know, it's implementation defined, but maybe not even for the whole buffer. So you can do these same kinds of tricks for your value-oriented types as well.
It's related to performance, but I think one of the problems maybe with advocating functional techniques in Swift, because the Westminster today is that we might accidentally be encouraging people to like write quadratic algorithms and stuff like that. From a teaching perspective, is it good to be upfront about that, do you think? Or maybe to put that off while they're learning and then get back to it?
Yeah, that's a great question. OK, so the question was, what about the fact that many naive implementations of functional algorithms have worse runtime semantics, runtime characteristics than equivalent imperative implementations? Yeah, that's a good question. I don't think there's necessarily an issue of like introducing upfront the concern, because at least any engineers I've been talking to, they see the problems. Like it's very clear. Whether or not it's a problem will depend on the specifics of your case. A lot of the time, we're willing to sacrifice performance in exchange for clearer code, and better semantics, and other times you should revert to, actually this is a thing I like a lot. Rob Ricks is a great human being and has a blog, whose name I'm also forgetting. You should Google for Rob Ricks and read his a blog post about hiding imperative stateful algorithms behind value-oriented APIs. And I think that's a great pattern. So okay, like make ugly stuff, but hide it. Okay, awesome, thank you.